Hi, welcome to my channel Asitgets. My name is Azrael, and if you're interested in a simple definition of quantum physics and why it's so important, stay tuned. Alright, I'm just gonna hop right into it. The simple definition of quantum physics is a study that analyzes how atoms work and why chemistry and biology work as they do. Everything from the sun to us, the plants, and even materials all dance to this quantum tune. Now, I'm going to go ahead and slip in a video for you guys in order to show the quantum physics experiment and exactly what they found.
The infamous double slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum. An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern. We fired electrons, tiny bits of matter through. But we get a pattern like waves, not like little marbles. How? How could pieces of matter create an interference pattern like a wave? It doesn't make sense. But physicists are clever. They thought, maybe those little balls are bouncing off each other and creating that pattern. So, they decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits and it goes through neither. And it goes through just one and it goes through just the other. All of these possibilities are in superposition with each other. But physicists were completely baffled by this. So they decided to peek and see which slit it actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched. And it was here that physicists stepped forever into the strange, never world of quantum events. What is matter? Marbles or waves? And waves of what? And what does an observer have to do with any of this? The observer collapsed the wave function simply by observing.
All right, I know that looks like something straight out of a sci-fi. It sounds like something straight out of a sci-fi. Simple fact, because at the end of the day, after that experiment and what the scientists has found, you cannot do anything but accept the fact that everything is always in constant movement. These tiny little atoms, literally that makes up everything are always moving. They're always, and we don't know where they're going. We don't know why they pop up the way that they do. We don't know why they behave the way that they do. But this discovery is literally scratching at the iceberg, the tip of the iceberg, like literally. Quantum physics explains to you exactly how everything works and how they interact, and it's just, I don't know. Every time I'm thinking about quantum physics, I get super excited and mind boggled and amazed, and I don't know. I'm a bit of a science nerd, but it just makes me so excited because with this new discovery, which is not new, this has been found for over 100 years ago, and not only that, it's not even in the school books. That's why I feel like it's so important for this to become common knowledge, because with this new set of knowledge, you don't have a choice but to kind of think differently or see things differently, because yeah, like literally this is a solid object. It's not moving, it's not bending, it's not going to do anything. You know what I'm saying? But however, on a tiny molecular level, you get a microscope that's strong enough to see down deep in there into these atoms. These atoms are literally bouncing around. They're moving. Although this is a solid, it's moving. And the only reason why this is solid, because my consciousness is on this, and therefore the atoms know to behave and stay still. Therefore, some scientists are out there saying nothing is real. Nothing is literally real. The only reason why it's real is because we make it real. Quote unquote, if this camera wasn't here and I wasn't paying no mind to what's back here, this technically, in the science, according to quantum physics, this does not exist. This is just, I don't know, some hazy, dark area that has no existence, but as soon as I turn around and I look and I put my consciousness on it, boom, it's there. Like, oh my gosh. Yeah. I think that is so cool. And then the fact that this law goes for everything. Everything. Lasers, light, solids, you, me, animals, plants, everything. Like, I just think that's cool. I don't know if you guys see how cool this is. I'm such a dork. But I think that's really dope. And with this becoming common knowledge, I think it's very important, because this will push our little kids, you know what I'm saying, to want to discover more and make even greater discoveries, you know what I'm saying? It's just really sad that this is not common knowledge. This is not being taught in school, but it's okay, you know, we know why. but yeah, I'm gonna keep this short and sweet, simple. I hope you guys enjoyed this video. Yeah, if you did, leave a like or a comment. I'll see you guys next week. Bye.